This is part 8 of section 4.4. Simple harmonic motion. An object whose position relative to an equilibrium point at time t can be described by either y equal to a times sine of omega t or y is equal to a cosine of omega t, where omega is a positive number. It's called simple harmonic motion. Basically, what we're talking about is, in the example we're going to talk about is a spring. If you have a spring and it hasn't been pulled, it's not doing anything, and this would be your baseline at an equilibrium point. If you pull the spring down, then it's going to bounce up and then down and then up and down and so on. And you create what is relatively, it's either a sine function or a cosine function. It can be either one. Okay? If we have that, then the amplitude is the maximum distance the object travels from its equilibrium point. Okay? And the period of the motion is 2 pi omega. And the period is the time it takes for the object to complete one full cycle. And then the frequency is the reciprocal of the period. That gives us the number of cycles that we can complete in 1 unit of time. So let's talk about this type of example problem. Suppose a ball attached to a spring is pulled down 4 inches and released, and the resulting simple harmonic motion has a period of 3 seconds. Write an equation for the ball's simple harmonic motion. Okay? Well, if we have our equilibrium point and we start off by pulling the spring down, we've pulled it down 4 inches. Then if we just think about how the ball is going to go over time, it's going to start going up and then down and then up. We need to decide whether it makes the most sense to be dealing with a sine function or a cosine function. And again, if you're starting off at 0, sine makes the most sense. If you're starting off above or below that, then cosine makes the most sense. And our amplitude is going to be 4. It's the maximum distance we are pulled away from equilibrium. Now our a value, so it's either going to be 4 or negative 4. Since we start off below the x-axis because we have pulled the ball down, we're going to use our a value at negative 4. Okay? So what we have so far, we have y, we're going to be doing something of this form, y is equal to a times cosine of omega t. And now we know our a value is negative 4. Now we just need to find omega. The other bit of information we're given is that the period is 3 seconds. The period is 2 pi over omega. And we know that this equals 3 seconds. And we can solve this for omega. We would have 2 pi is equal to 3 omega. So omega is equal to 2 pi over 3. So if we want an equation that models this harmonic motion, we can now say that it is y is equal to negative 4 cosine of 2 pi over 3 t.